Alright, let's get started with lesson 3. Solve equations and inequalities with variables on both sides. Now this is just another extension to our solving equations. And it's not a big leap. There's really only one minor detail that we're going to add in. I'm going to show you a trick so that you can help yourself whenever you are solving these. So on the left we have an equation, on the right we have an inequality. Now when I say variables on both sides, that's what I mean. On the left side here's a variable, on the right side we have a variable. Now this provides an issue because, as you know, we only need a variable on one side. So if you ever see an equation or an inequality that looks like this, after you have simplified everything as far as you can, and you get to this step, you want to first and foremost move the variables to the same side. And then it becomes a problem like we've been working on. Now here's the trick that I'm going to let you in on. Whenever you move the variable, you want to move the small variable to the bigger side. So we want to move the small variable to the big side, because if you do that, you will always work with a positive number with your variable. So if we look here, we have 3x and 2x. Well, 2x is smaller, so we're going to move the 2x over here. So we're going to subtract 2x. Reduces here. 3x minus 2x is 1x plus 2 equals 7. And after we do that, now it becomes a problem we've been working with the past couple lessons. We subtract 2 and we get x equals 5. So there's not a whole lot different to this, it's just adding in that one little step. So if we look at the inequality, we have variables on both sides. We have 4x and 7x. So we need to move the smaller to the bigger. So to move 4x, we subtract 4x. So we're left with negative 8 is greater than. 7x minus 4x is 3x plus 4. Now we just solve like we normally would. Subtract 4. Divide by 3. And again, our inequality symbol is not going to switch because this is a positive 3 we're dividing by. It only works with the number that you multiply or divide by. Greater than x, but that looks weird, so we're going to switch to get this. And that's how you solve with variables on both sides. So here are 4 examples of equations with variables on both sides, and I want you to, in your group, pause the video and work through these 4 examples. Go ahead and pause the video now. So go ahead and work on these in your group and then play the video again to see the answers. And here are the solutions to those examples. I want you to pay close attention to number 2. You saw here it's a little different because we had a and negative 5a, and you kind of have to stop and think and realize that the negative 5 is going to be smaller than the 1a. So go ahead, pause the video again, go over these to make sure that you did them alright, and confer with your group if you got something wrong, see if you can figure it out. Okay, and here are 4 examples of inequalities with variables on both sides. So again, please pause the video and work through these in your group. So go ahead and do that now. Okay, and here are the solutions to the 4 examples. And as you can see here, it's very nice if you are able to move the smaller number to the bigger side, because you don't have to deal with negative numbers and flipping those inequalities. It just kind of saves you one step that you might accidentally make a mistake on. And then I'd also like for you to pay attention to 4. As you saw here, 4, you had to do one step before you could actually move your variables, and that was just simplifying. So please make sure that you do simplify things before you start moving the variables. On to our last idea of this lesson, special cases. Sometimes whenever we work with variables on both sides, we run into special cases. So let's start with number 1. Number 1, I'm going to solve this. I look, x and x. Well, neither one's really smaller than the other, so it doesn't really matter which one I subtract. So I subtract x, and I wind up with 5 equals 5, which I don't have a variable anymore, but I do know that 5 equals 5. So what I want you to do now is pause the video and discuss in your group, what do you think this 5 equal 5 means? Okay, well, what 5 equal 5 means, it just says that x can equal any real number. What that means is that if you get an answer like this, where 5 equals 5, 2 equals 2, -1 equals -1, it means that no matter what number you put in for x, it will always make this statement true. So let's go over here to 2. On 2 we have y and y, so again, doesn't matter, so we subtract y, and we're left with -5 equals 3. But we do know that -5 doesn't equal 3. So what does this mean? I want you to pause the video and discuss this in your group now. Okay, as I'm sure you could conclude that this is a bit different than our first case, where it's not true. Well, if this is true, then that means that there is no solution here. It means that there's no number we can find for y that will make this ever true. 3 is similar case. It looks a bit similar to case 2, but let's actually work through it. We have the same variable, so there's no smaller, so let's just subtract x. And we see that 5 is greater than or equal to 3. Now what I want you to do is, in your group, pause your video again, and I want you to look though, is this statement true or not? So think about that when you pause the video and talk now. Okay, this statement right here is true. So the statement's true. Well, if the statement's true, that means that x can be any real number. It's all about, is it true or is it false? If it's true, then it's any real number. If it's false, then it's going to be a no solution. So let's look at 4. We are going to subtract y from both sides. We see that -2 is greater than 2. Well, we know that this is not true. Well, if it's not true, then that must mean that there is no solution. And I actually shouldn't put y equals, I should just put no solution. So let's get rid of that in the one above too, where it says y equals no solution. Let's get rid of that there. And that is the end of this lesson.